Hey everybody, so we're going to do a little notes session on some reactions of acids and bases. So a lot of times you hear acid-base reactions and you might think because of that there's only one type of reaction between acids and bases, but that's not actually true. They're pretty complex reactions, but we can break them down into a few categories, and we're going to go over 4 types of reactions that acids and bases undergo. So the first type we're going to look at is just a simple acid plus base reaction, and this is called a neutralization reaction. So in a neutralization reaction, you have an acid and a base that react together, and generally what's going to happen is that they produce a salt and water. So a salt is not just like salt, table salt, NaCl. A salt actually refers to an ionic compound. Any ionic compound can be called a salt. And the salts that are produced from neutralization reactions will generally remain dissolved in solution. So think for a second what state of matter we call dissolved in solution. Think about how we might write it in our reaction format when we start predicting products. So in general, your general reaction format, you're going to have an acid plus a base. They react together to produce water. Water is a pure liquid, and a salt. So how do we write dissolved in water or dissolved in solution? Boom, aqueous. All right, so let's take a look at one example. We're going to predict the products for this reaction here. First, let's decide what's our acid and what's our base. Excuse me. So hopefully you notice immediately you have K with an OH in it, KOH, potassium hydroxide. We said that anytime we see that OH, it's a good indicator that that is a base. HCl, on the other hand, is one of our very commonly known acids. So this means here is our acid, here is our base. So hydrochloric acid, HCl, because it is an acid, it means it's going to donate its hydrogen, it's going to donate its proton. So it's going to get rid of that hydrogen. Where is it going to go? Well, it's going to form water by reacting with the hydroxyl OH of our base. So these two things are going to come together to form our water. And then what's going to be left over is our salts. So what's going to form our salts? Well, it's going to be potassium from this compound here and chlorine from this compound here. Okay, if we're making an ionic compound, that means that in order to make this, they have to come together in a specific ratio to make sure their charges balance out. So we have to crisscross charges. So if you forgot all about your charges of your ions, you better get your personal periodic table ready because you have that charge trend on there. So potassium, group 1 metal, which means when it ionizes, it gets a +1 charge. Chlorine is a group 7. It is a halogen. So when it ionizes, it's going to gain, oh my God, look at that. It's going to gain an electron to become negatively charged. So when we crisscross our charges, boom, 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 1 comes down, boom, 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 1 comes down, and we end up with KCl. And we said this is going to stay dissolved in our solution, so we're going to write it as aqueous. Lastly, just do a quick check to make sure everything looks balanced, and in this case it is. Good to go. All right, our second type of reaction we're going to look at can be called by kind of 2 names. This is also a neutralization reaction, but it's a very specific one. So we're going to call this a gas evolution reaction or gas producing reaction. There is one other type of reaction we're going to look at that does produce a gas. This is just one type of them. So when an acid reacts with a compound that contains either carbonate, the carbonate ion, CO3 2-, or contains bicarbonate, HCO3 1-, a neutralization reaction occurs. that results in the formation of 3 products. This time you're going to have water. You're also going to have a salt, just like the neutralization reaction before, but this time you're producing a gas. What gas are you making? Carbon dioxide. Okay, so let's write out our general reaction format. You have an acid, and it reacts with either some ionic compound, metal that contains the carbonate ion, or some ionic compound, we'll say metal, that contains, or that is bonded to the bicarbonate ion. But both of these are going to result in the same products. You're going to have liquid water, you're going to have carbon dioxide gas, and you're going to have some salts. So let's take a look at one example here. So in this example, we have HCl. This is our acid reacting with our bicarbonate containing compound HCO3. So this is sodium bicarbonate, baking soda. So when these things react together, we're going to produce water, H2O, liquid. We're going to make some carbon dioxide, CO2 gas, and we're going to make a salt. What salt do we make? Well, we have our Na, our cation over here, which is going to bond with our Cl over there. So these two things are going to come together to form an ionic compound. So take a second, pause the video, see if you can crisscross your charges. What ionic compound are we going to make? We're going to make NaCl. All right, so there is our reaction type 2. Moving on to type 3. In type 3, these are going to be our acid metal reactions. So if you have a metal that comes into contact with an acid, the acid can dissolve that metal, causing it to go into solution. But just to be clear, this doesn't happen for all acids with all metals. So we're just going to assume that if I give you one of this type that matches this description, we're assuming that the reaction will happen. So if the acid dissolves the metal, this is going to result in the formation of a salt, like always. This also results in the production of hydrogen gas. So this is another gas-forming reaction, but this time it's acid metal. So general reaction format, you have an acid, reacts with a metal. We're producing H2 gas and a salt that will stay dissolved in solution. So let's think about what's going to happen with this example right here. H2SO4, this is sulfuric acid. Zinc is our metal. So we know that we're going to produce H2 gas, comes from the hydrogen in sulfuric acid. And now we're going to make a salt. So our cations are going to be right here coming from the zinc metal. Our anion is the sulfate ion that comes from sulfuric acid. So pause the video, take a second to crisscross your charges, see if you can get what the formula of the salt's going to be. Hopefully you remembered that zinc only ever has a +2 charge, so these things are going to come together in a 1-to-1 ratio to make zinc sulfate dissolved in solution. Take a second to make sure it's balanced. Looks good, and we're moving on. Last one. So reaction type 4. This time we're going to have an acid metal oxide reaction. So when an acid reacts with a metal oxide, what are we going to make? We're going to make water and a salt. So we'll think about how this one's a little bit different from the acid metal reaction before. A metal oxide is a metal bonded to oxygen. So we have acid plus some metal oxide. These are reacting together to make water, which I'll write as the formula, H2O, liquid plus a salt, which will stay dissolved in solution. So let's take a look at our example. We got HBr, hydrobromic acid, reacting with sodium oxide. This must be our acid, and this is our metal oxide. Okay, so where is this water going to come from? Well, our hydrogen comes from our acid, and that's going to react with the oxygen in the metal oxide. And these two things are going to come together to form our water. So unlike the previous problem, we just had a metal. It was not a metal oxide. No oxygen was present there. So we're not going to make water in those. We're just forming hydrogen gas that's coming where the hydrogen comes from the acid. So here, hydrobromic acid plus Na2O, sodium oxide, are going to make our water, H2O. And then we're going to form a salt. So this time we got sodium, we got bromine. Pause the video, figure out if you can get the formula for the ionic compound that gets formed. All right, hopefully this is what you ended up with. NaBr, it's going to stay dissolved in solution. It's going to be aqueous. Take a second to look at that. Immediately your head should start pounding and you should shed a small tear. Our reaction's not balanced yet. No, we must do it ourselves. So how can I balance it? Well, if I put a 2 right there, that takes care of the whole thing. Easy enough. So these are our 4 types of reactions of acids and bases that we're going to look at. So what I want you to do is take a look at the next page, look at those 4 practice problems, see if you can match up the reactants and predict the products for each of the reactions that will happen based off of the 4 reaction types that we just took a look at on page 10. Once you're finished, check your answer with the answer key, and you're done.